Good afternoon, everyone. This is your host of the evening, Brahmajit Mohapatra. It's a great pleasure of mine to welcome you all to the community learning session on behalf of AWS Cloud Community LPU, a platform where we will take you to the depth of the concepts in AWS. This happens every Sunday, and stay tuned with us to learn more about AWS. Talking about what is this AWS Cloud Community LPU is all about. So this is a club, an organization which empowers all the willing students to shape a community where everyone is responsible and dedicated and also ready to explore and experiment new possibilities using AWS platform. This community aims to reach to the maximum and maximum of their availability so that they can teach the students, the freshers, how to use the AWS platform. We conduct so many of events, and we also conduct frequently the workshops and competitions, and we also organize community um, like community learning sessions every Sunday. So these workshops will teach all the attendees like how to make the best use of this amazing platform. So talking about today, today our afternoon will start with the introduction to Docker and followed by Amazon ECS on the next Sunday. Please note the date. It will be continued on May 16, 2021, which is on next Sunday. So talking about what is Docker. Do anyone know what is Docker? So Docker is a tool designed to make it easier to create, deploy, and run applications by using containers. Containers allow a developer to package up an application with all of the part it needs, such as libraries and other dependencies, and deploy it as one package. It will be really helpful for you to know about how Docker works, how it all happens in a sequential way. And for that, I have Mr. Rajit Paul with us. So, introducing you to the speaker of the day, he is a man of humbleness and great qualities. He is a persistent explorer of technologies, and not to mention that he is the core team head of AWS Cloud Community LPU. He is also trained in MLOps, hybrid multi-cloud, and he is also good in app development. So, ladies and gentlemen, put your hands together and let's welcome Mr. Rajit Paul.
Thank you, Brahmajit, for such a wonderful introduction. And
Thank you so much.
we have been on a break, and we are glad that we could be back with these community learning sessions so that we could reach to the AWS enthusiast and can share this platform together. So, thank you so much. Without further ado, I'd like to start,
Yes, sir.
and let me quickly share my screen. Let us go ahead with, yeah, I hope my screen is visible.
Yes, sir, it is visible.
Thank you so much, Brahmajit.
Thank you.
Uh, so, guys, hello, welcome, and I hope you had a long break and you all are healthy and safe at your own place. So, these are tough times, and we have to be tougher, and we have to persist through all of this, so that we can, save our nation, save the world, and save humanity. So, wish you all a safe and happy life. Thank you. So, first of all, our agenda of the day today would be to go ahead and learn about Docker. So, that would be our main agenda for the day. That what is Docker? What are containers? What are virtual machines? Right. So once we have that knowledge, then we can take that and proceed to our next week. That is the part 2 of introduction to Docker and AWS ECS, where we'll be going through the hands-on practical and the hands-on demonstration on AWS ECS, right? So let me quickly give you a brief about virtual machines, and then we can go forward with containerization or what are container technologies. So let me switch my screen a bit. One moment. Let me just quickly switch my screen to the. Just a moment, guys. Let me just quickly switch my screen. Yeah. So okay. So yeah, I hope my screen is visible now. So this that I'm using currently is a VM, right? So what is a VM? A VM is like a virtual machine. Okay. We are using. I have my base OS as Ubuntu, which is the base OS that is running on top of my hardware, and on top of that, you can go ahead and deploy your own OS that you want to. For example, I'm using Ubuntu. On top of that, I'm using a layer of hypervisor, and on top of that, I am going ahead and using a VM, which is a virtual machine. So what is the use of virtual machines? So virtual machines, as you can see, is a complete OS. Like I can go ahead, I have a terminal to myself, and I can go ahead and do whatever I want to. Like I can go ahead and create a web server using Apache HTTPD, and I can launch my web server, right? And I can do whatever I want to. Like this is a complete OS. If I go ahead and check the file system, I can see in the GUI as well as in the CLI that everything that is required for a functioning OS, a complete functioning OS, I have that, right? So this is what is known as a virtual machine. Why it is known as a virtual machine? Because this is virtual. This is not physically like present. Actually, it is there, but it is not physically on top of my hardware directly. There is a layer, the layer that is known as the hypervisor. So the hypervisor is the layer on top of which the VM sits, right? So the OS that is on top of the hardware directly, it is known as the base OS. Okay, so whenever you have a laptop, you install Windows, you install Ubuntu on it. So that is the base OS that you install on top of your on top of your hardware. And on that, you put a hypervisor layer. So that hypervisor layer I'm using with VirtualBox, right? The VirtualBox software provides me that hypervisor, on top of which I can go ahead and run multiple VMs, multiple virtual machines. So that capability is provided by hypervisor. So hypervisor is just a layer on top of a hardware that helps us to do that. Like for VirtualBox, we have a certain type of hypervisor. For Windows, you can go ahead and see that there is a Hyper-V. For AWS, there is a Zen hypervisor. So these are the hypervisor that lets us run the VM on top, right? So I can launch multiple VMs like this. So what is the use? So now the use case of this is, for example, I have my base OS, and on top of my base OS, say for example, I have launched the web server directly on top of my base OS. So just quickly, let me share my screen one more time so that you can understand what I'm talking about, right? So for example, my base OS, I have launched it, right? So let me share my entire screen. So for example, this is my base OS, right? On top of my base OS, I'm using Ubuntu, and on top of it, I have deployed a web server. Now what happens is that if I go ahead and start using the web server directly on top of my base OS, then if my OS crashes, by chance if my OS crashes, I won't have a web server running. And so when the when my clients will hit my web server that is hosted on my base OS, they won't get something like this. For example, this is something that I already have. right? So they won't be getting something like this. Okay, so they will get something such as the website is down or something like that. Okay, so if we hit a server which is non-existent, say for example, uh, this is non-existent, right? So it will not connect. Okay, sorry, there was some domain by this name. Let us go ahead and use a famous one and just try. So instead of LinkedIn, I use one here. So this is like, this site can't be reached. Okay, so this is a page which shows that the web server is down. Okay, so this status is like maybe internal bad gateway or something like that. Okay, so this is which is not acceptable by many companies. Okay, so companies cannot have a web server that is service to provide 24/7, but it goes down. So in that scenario, if I am launching the web server on top of my base OS and the website crashes, then what do I need to do? I need to install a base OS completely from scratch. Then I need to go ahead and then I need to fix the web server, whatever the bug is there, and then I'll have a web app running. Okay, so this time I cannot dedicate to just installing a new OS, then setting up a web server. So that is why base OS is out of the question, which is the first layer. Consider is the first layer, the first the first approach. Like for example, for you setting up a web application or whatever application you have, you can do it on base OS. But as you saw right now, that base OS is out of the question, because we cannot go ahead and do it one more time, like install and 1 hour of time that we require to format and then install the web server. So it is out of the question. What is the second option? The second option, let me share my screen once again. The second option, as you know, it's VM, virtual machines, right? So virtual machines is a better way of deploying whatever application you have, so that if a virtual machine goes down, it takes less time to provision another VM. But it still takes around 20 to 30 minutes, right? It will still take around that time for us to go ahead and install a virtual machine, and then provide the image, then come here and install whatever OS you have with the package manager, to go ahead and install the Apache web server package, to set up everything. So this will take time. This will take at least around half an hour, right? And then when once we go ahead and set it up, then we have a web server running. So half an hour, is it okay for the companies to wait for half an hour? For example, my website is running, and uh, here, and by chance my web server crashes. So is it okay, my company my company is front facing website, when people will come onto that, they will see that it is down. Is it possible? It's not possible, right? We cannot go for that. So in that scenario, what we can go for is, we can go for another alternative. So as of now, let us look at that alternative in a more better perspective, right? So let me just quickly go to localhost, and as of now we see that this is running. So by chance this goes down, okay, by chance this goes down, and let me quickly remove the, or let me just stop the service. So this stopping the HTTPD service, consider it as equivalent to my OS being crashing, or my server going down. Okay, so when I'll stop this, I'll just go ahead and share this. It will say unable to connect, means my website is down. Okay, so now what I need to do is, for example, my OS crashed. In this case, I have just stopped the service, but for example, my OS crashed. So what do I need to do? I need to go ahead and install another VM like this once again, and install all the packages and everything, another 30 minutes. So for 30 minutes, my clients will come to the website, and they will see that my website is down. Is it okay? It's not, because I cannot hamper my reputation, because clients coming and dedicating their time, and they just seeing that my service is down, is a big letdown for my clients. Okay, so in that scenario, what alternatives do we have? So we saw that we cannot go for base OS, because base OS is not a proper solution for me going and deploying all my web server. It is not. Then we saw that VM, our VM, a way of putting forward my website, and if my web server crashes, then I need to go ahead and launch another VM that will take another 20-30 minutes. It is not right. So what is another alternative? Another alternative is containers. So what are containers? You can say another name for container is Docker, not because Docker is the only one providing container service, or it is the only container management platform or container runtime. There are others such as Podman, Cryo, but Docker is the face of containerization technology. So if you ask people about container, they will say Docker. They might not know about container, but they know about Docker. This is how big the platform is, right? So let us look at the what is Docker. Before that, let us just take a look at their web app. This is a wonderful web app. Just see, the UI and everything is so wonderful. So Docker makes development efficient and predictable. What is it saying is that for development, what do you mean by development? For example, you are creating a web application, you are building it, testing it, and then you have you are deploying it, delivering it. So this entire process, you can say, software development. So Docker makes this development life cycle, or you can say the development part, efficient. Means you don't have to worry too much, or you don't, it is not like a rigorous process. Okay. So Docker makes this entire creation very, very, very lightweighted and very efficient. So we will look how. Okay. So they also mentioned that Docker takes away repetitive, mundane configuration tasks and is used throughout the development lifecycle for fast, easy, portable application development. Right? Just as we mentioned right now. Okay. Desktop and cloud. You can go for desktop as well as you can deploy Docker on cloud. Okay. Docker's comprehensive end-to-end platform includes UI, CLIs, APIs, and security that are engineered to work together across the entire application delivery lifecycle. So what this point, let us go through that one more time. Is Docker comprehensive end-to-end platform? So Docker is a platform. It includes a user interface. It has also CLIs. You can use Docker from the CLI itself. It has also APIs, application interfaces, and security that are created in a way to work together across the entire application delivery lifecycle, right? It helps you work together all of these facets, all of these components across the entire application delivery life cycle, and it helps you to work together, right? So these are not independent, these are merged together. Okay. So we'll go through all of this. Once we go through the practical, it will be more clear to you. So you can see that build, share, run, you can all do that with ease in Docker. Okay. So all of our favorite tools, for example, Bitbucket, CircleCI, Elastic, GitLab, Jenkins, GitHub, Nginx, MongoDB, Kubernetes, JFrog, Redis, VS Code, VMware, all of this can be deployed using Docker. How we will get to that. Okay. And then you can see the companies that are using Docker, starting from Adobe, AT&T, Palo Alto, Netflix, PayPal, Pipedrive, Stripe, Verizon, Snowflake, all Splunk, all of them are using Docker. And you can also see the cloud providers such as AWS, Azure, Cynic, JFrog, all of them are using and deploying Docker. Okay. So now that we know, like on the front facing, like the web app, or we know that this is Docker, I'll quickly share this link in the chat. Okay. So you can go ahead and take a look at that. All right. So yeah, so now, as of now, we know that what is Docker. Let us go forward and let us see and deploy. Okay. Let us quickly get our hands dirty and let us get into what is Docker. Okay. So yeah, I'll just quickly go back to the VM. Okay. So yeah, so let us now see that what is Docker. So for example, first of all, what you need to do is you need to install Docker. So for that, for Windows there is a different procedure, for Linux there is a different procedure, but it's simple. It's you just click install. Or for for Windows, you can go for something else. Linux, you install a tar file. For Windows, there is Docker Desktop. So depending on the platform, you can just go for this, like Docker Desktop for Mac. This is a platform. And for Windows, there is a different. And also for all the Linux distributions, CentOS, Debian, Fedora, Raspbian, and Ubuntu. Okay, you can go ahead and install Docker. So let me just quickly also share this link on the chat so that you can go ahead and install Docker. Okay, so we will not be going through the installation. It's a simple procedure. It's all mentioned on the web app itself. Just go to their website and you can see that. All right, so once we have installed it, it's just like once we install any kind of package in Linux, it is something that like that we have to go ahead and start it. So for example, we will be using the systemd service starter and systemctl, and we will go ahead and start the Docker service. Okay, so this is as the command. Now we have our Docker running. So let me run the Docker version. When we run the Docker version, I can see that my Docker version is this. Okay, this is not the latest one, but yeah, we'll be using this one for today's demo. Okay, so now we have Docker. So now let us understand what is Docker. Docker, as you saw, that it is a platform. You can also say that it is a software which is making your complete software development lifecycle efficient, like starting from the build procedure, the run procedure, sharing, and everything is making efficient with the use of Docker. So now we have installed that tool and we have the service started. Okay, so now let us go ahead and start. For example, now let us go back to the analogy, or you can say that to the use case that we are mentioning. That, for example, I was launching a web server. Now I launched it on my base OS. It is taking me around 1 hour if my OS crashes. And then again, I can go ahead and launch it on my VM, and then it is taking me around 1 hour to not maybe less than 1 hour, 45 minutes, 30, 45 minutes. But still, that is a lot of time, and I have to redeploy or reprovision my VM, go ahead and install Docker, and then I can go ahead and host my or launch my web application. Right, sorry, not Docker. I have to install the HTTPD package, whatever it is, for the VM. Okay, now in case of Docker, this is another option we have. Let us see how much time does it take to launch me a web server. So I'll just use this. Let us provide a name to it, and I'll just explain what this command is doing and what is meant to do. Just let us use this. Okay, so okay, uh, let me just launched it in the detached mode. Okay, so you can see that just in 1 second, I have this container running. Just let us see now. What do I mean by this? You can see that I have launched a container by the name of WebOS 1. Let us see the IP. Okay, so the IP is this. Let me quickly copy this, and let me switch to Firefox. And yeah, let me quickly open this. So you just you could see that just within me launching the command, just in 1 second, just in 1 second, I have my container up and running. And when I go to this container IP, it shows my web server content. This is the content that is provided by the HTTPD image creators. You can go ahead and put your own content. We will see how today. Okay, so you could see just that in 1 second. In 1 second, I have this container running and I have my website deployed. Could you imagine, like, from 1 hour we came down to 30-45 minutes, and from 30-45 minutes we came down to 1 second, and in within 1 second we have our entire web server deployed. And for example, now that I mentioned the use case, that for example, that I have this container running, WebOS 1. So let us consider this, that my web server crashed. So let us just remove this container, on purpose. Okay, it is a running container, so I have to use forcefully. We'll go through all of these options in some time. Okay, so now my web server is down. Okay, as you can see, my clients coming to the web server, hitting it. There is no connectivity, it is just loading. There is no content here. Okay, so my clients will face that my web server is down. So as a backend admin, or you can say a monitoring guy, what I see that my container is down, I quickly go ahead and launch one more. Just like that, I quickly go ahead and launch it. Right, you can see that now it was coming down, my website is down. Just let me go ahead, you see, within 1 second my my web server is up. This is the magic, or this is the main USP of Docker, that it is instant. You can have your applications backed up in multiple containers. One goes down, another is already up. Worst case scenario, everyone goes down, you can just launch one more within 1 second. You don't need minutes, you don't need hours to do it. You can just do it in seconds. Right, so this is the main USP of Docker. This is how the whole industry, all of those companies that you saw, they all are using Docker just because of this. Okay, so now that you understood why, like how like Docker is so powerful, let us understand, let us see how we can use this. Okay, so let us first go it step by step. So the first command that I launched was docker run it name. Let me give another name to it, and I use the image. Okay, and I launched a Docker container. Okay, so yeah, so we have to use, as this is a web server container, we have to use D. What is D? I'll also mention it to you. Okay, all right, there is something by this name. Let us use WebOS 3. Okay, it is launched, right? This is just in 1 second this container is launched. And if we go ahead and check the IP of that container, let me quickly check the IP. It's 03. Let me go ahead and switch to 03. Okay, so it is the same image that we use, the same content, but it is working, right? We launched one container. Now let us go through the command that we used to do so. So as you can see, the software or the platform that we are using is Docker, and we are asking Docker to run what? Run containers. Okay, so you don't need to, you can go ahead and mention containers here as well. You can go ahead and mention containers like Docker run container. And then let us go for another. Wait, containers latest locally. Okay, maybe it is, okay, sorry, I misspelled it. Okay, okay, let me check. There was a different name for it, I suppose, or might be possible. Okay, we will check, we will go through this. Yeah, there was some, there was some command variation that was once provided. I don't know if it's still working or not. Let me quickly check. Docker run container. Okay, let me quickly check here in documentation. Okay, we can use, yeah, we can use, we just saw that, yeah, we are using this normal. No containers mentioned in that. Okay, so no worries. So yeah, we are just using run what? Run containers. And now we are providing few options here. What are these options? These options, the first one, you can say, we'll go through the D part once later. The I option says that it is interactive. Means you can interact with the container. What do I mean by interact with the container? We will see shortly, that within a minute right now. Okay, that we can interact. And T is terminal. Okay, so what do I mean by interact? Let us see. So for example, I have launched few containers, two containers to be specific, WebOS 1 and WebOS 3. These are two containers, and these are launched with this web server, right? So now if I want to go inside one of the containers, so I say that I want to exec. Okay, and I say that yeah, I want to go inside WebOS 3, and I want to use the bash functionality. Okay, so you can see that I went inside the container. Now I can do whatever, like inside I have an entire OS. Can you just imagine, like we have an entire OS and deployed, and we deployed that within 1 second. Like we have every bin directory, dev, home, these are all the Linux file system directories, and we have everything present. Okay, so now once we are inside the container, we can do whatever we want to. So this is the part that is mentioned by interactive. I can interact with my container. I can go ahead and go to that part where my web server is deployed, and yeah, htdocs, and there is a file called index.html. Okay, so yeah, index.html is a basic page, that a home page kind of for your web server. So now if I want to deploy my own content, that yeah, I have now learned about Docker and I want to use my content. So I want to use hello wonderful folks, welcome to AWS community learning sessions LPU. All right, and now I go ahead, and as we have changed the content, let me restart, or yeah, just let me, it's already running. Okay, so now let me go ahead and quickly switch. So now you can see that we are using our own content now. Based on your HTML skills, like background, font, whatever are your HTML skills, you can deploy that. So there is no question about that, what you can do with it. Whatever you know about HTML, you can go ahead and completely do it here. So now what is the main point here? What is the main important point here? The main important point here is that we can go ahead and uh, remove this container and deploy a new container within just 1 second, right? So this is the main part. And also that we launched a container and we went inside it. Okay, so that is with the help of this I functionality, which is the interactive. And what interactive provided us? The terminal. This is the terminal, right? So this is the use of hyphen t. Okay, so now what is the issue? The issue here is using, just going with uh, hyphen it while launching the container. So this is the exact part. While we are launching, if we just go with hyphen it that you saw, and let me just show you this part. We are going with this, the hyphen it. Okay, so it is saying that it is on for some time, and after that it is shutting down. Why it is happening so is that because you can see that this is a service. Okay, the bash that I'm running, if you go ahead and just we go ahead and check with the ps-aux, we can say that bash, it is a process. It is like a process that you run. For example, excuse me, for example, I'm running the date command, the cal command, I'm running the Firefox. These are all process. Okay, so along with this process, bash is also a process. So now when we go ahead and we are using our web deploying our web server using httpd. Now httpd creators, what they have done, they have said that we don't want the bash, this bash, the process that we saw, the bash process, to be the front process, like this bash process. Yeah, the bash, this process that we are currently using right now, we don't want it to be the initial or the starting process for httpd, because our use case for httpd is something different. Okay, so for the use case of httpd is that we want it to render our our website, right? So now what we are going and saying is, if we go by it, we are saying that Docker, please ask HTTPD to provide us a directly bash terminal, right? Directly bash terminal where we can go ahead and work. For example, instead of HTTPD, if we use Ubuntu, if we go ahead and use Ubuntu, Okay, WebOS 5 is there. Let me use, uh, Ubuntu OS. Okay, so now that I go ahead and use Ubuntu, now you can see that I have the terminal, because in Ubuntu the creator have put it in a way that they have put the bash service as the main service, and we can, directly when we run it, we land on that service and we can use that, which is the bash process. Okay, so I can go ahead and, run all my Ubuntu commands and everything I can run here. Okay, so this depends on the creator. Now for, now for the web app, for the HTTPD that we are using here, if we go ahead by this, that we wanted to directly run an interactive terminal, but the HTTPD creator has said that we don't want that. What we have created it with, we wanted to provide a service. The service is the prime focus for us, and that is the main process. So that will be running. So that is the main part that will be running. Okay, so bash is not the main process. So when I directly go with -it, I land on this service. I don't have a terminal. See, I don't have a terminal like this. In this I have a terminal, but in this one I don't have a terminal. So this depends on the creator of the image who created it. He said that I don't want you to come to this terminal, and that is not necessary, but someone, when someone will run it, the service will be running. And when you go to this, go to this IP. So for example, this IP is 172.17.5. Okay, so when someone goes to this IP, they can see the web server that is running. That is more important. You see, when I go to this IP, yeah, it is now unable to connect because I have launched it like this. Okay, and it's shut down gracefully, right? So it caught a switch and it's shut down gracefully, right? So the main concern for them is that the service is running, and when we started, the service will be running, so that will render my website. I can go ahead and connect to that. So now in this scenario where we don't want a terminal, we just want the container running, and inside container, whatever the creator has placed in it, it will run like that. So there we use -d. -d is what? -d is detached. Like we say that we don't want you to provide and start and try to provide me a terminal. You just start the container. That is enough for me. And once you start the container, I will just get the IP. Okay, I'll just get the IP. Sorry, I misspelled the inspect part. Yeah, the IP for this one would be. Let me check. Yeah, I think we can directly go the grep. Yeah, and for this, yeah, the network card is something different. So let me check with this command only. So yeah, no IP address is provided. Why so? Let me quickly check. Docker ps. Okay, that is WebOS 7. All right. Yeah, so it's 5, right? So I'll just quickly, launch it, quickly go ahead and check that. Yeah, so this purpose is served. Whatever I wanted with this command, this purpose is served, and that is okay for me. Okay, now I also showed you that if you want to go later and use, the docker exec command to get inside the container. Say for example, I'm using docker exec -it, and I'm using WebOS 7, and I'm using the bash. Now what I'm saying is that run this process, bash process. I want to get inside the container, and then I can get inside the container. And for example, I want the docker container to just run the date command. So it will just run the date command, and then it will return me back to my own base docker host terminal. So it depends. I am saying, in the beginning I am saying it that launch the container, like I want to execute this container with an interactive terminal. So what you need to do is you just need to run this process, date process. So the date process takes 1 second, or to launch. So it shows me the output, and after it has completed its own task, it is done, right? It will exit. Now when I'm using the bash process, the bash process keeps on running. It keeps on running until what time? Until that, okay, sorry, the ps of command is not available here. Let me check if top is available. Top is also not available. Okay, So yeah, um, you can see it's been bash, right? And what we are running the bash process. So the bash process, it keeps on running. Okay, so it keeps on running till when? Till we run the exit command. Okay, now you can see that once we run the exit command, we are outside our docker container, right? So this part that we are using with the exec command, the process that we'll be providing, it is based on the lifetime of that process. The date commands take 1 second, so it ran and it exited within 1 second. Now the shell command, sorry, the bash command, it takes, it is like until and unless you say exit, and until and unless you exit the container, it will not, not be stopped or not get terminated. So that is the main part. Okay, with the docker exec command, and we also saw that. Now let us look into, so as of now guys, if you have any question, let me see. If we have any questions, we will address that. Okay, so please, if you have any questions, yeah, please ask them on the chat, or else we shall proceed. Okay, all right. So yeah, I feel we are good to go. So yeah, let us proceed. Can we create our own image like HTTPD? Yeah, glad you asked that, Sami. We are, yeah, definitely going to that part right now. We'll be creating our, we will see that, what are Docker images, and how they're different, and how we can create one. Okay, so yeah, the answer is yes, we can definitely do that, right? So now let us look into the part of Docker images. Okay, so I have a lot of images. Let me quickly, so these are all the, let me just switch to Docker images, less, or let us go for get more. Okay, Docker images. Okay, is it coming within one window? Yeah. Okay, so you can see that, for example, this is a web image that we have. Okay, so this is one of the images that we have, this is another image that we have. So depending on the use case, we can deploy our own images. So what are Docker images? Docker images are nothing but it is a repository, or you can say that it is a collection of all the applications and all the programs that are required to run a full-fledged OS. For example, for this OS, we have, our Ubuntu OS, we have the Ubuntu image. Now similarly for other Red Hat, we have the Red Hat image. So like that, what Docker has done is that Docker has created their own images for every application. So just let me quickly stop sharing, and take you to that part of Docker images. So yeah, just let me open this. Yeah, and let us quickly switch to that. Right. So in this is like, you can say, a central repository of all the Docker images, right? And in this, if you can go ahead and, if you go ahead and search, like for Ubuntu, you have one image, and for all the use cases, just you go for all the official images, and you can say, all the images that you have here, like for Ubuntu, and every other image. Like for example, we just choose Ubuntu as of now. Let us clear the search and just go for official images. Yeah, you can see all the official images are present here. So this is the central repository of all the Docker images, and based on your use case, you can see that, so many categories are provided. So for example, I have something required to databases, so I can go ahead and use this Redis image. So how we can use this Redis image is that this is a simple command that is there, that Docker pull Redis. I will just go ahead and copy this, and then in the description it is provided, how to use that. So in here it is provided that when you are running the Redis, you just run this command, a name and hyphen d Redis, and you will have your container available. So it is all provided in the documentation. So let me quickly zoom the screen. You can see that it is provided here, right? So if I just go ahead and I'll just go ahead and copy this link, just go ahead and paste it here in my VM, and we can directly use Redis. Okay, so this is the central repository which is known as Docker Hub, where you have all the images, and you can also go ahead and use them as per your use case. Okay, as per your use case, in the left panel you can see you can go ahead and use them. And in here there is another concept as well, that these are all the community served or official images that are served on the Docker Hub. So can we have our own image? We definitely can. For example, I have an account by the name of this submarine, right? So I have launched my own Docker images. Okay, so you can go ahead and do that. So for that we'll have another demo on how to create the Docker images, and we will answer and all the questions related to that and see that how we can do that. But yes, we can definitely create our own Docker images. Okay, so yeah, I hope the answer is clear to that part. So now let me quickly go to the VM one more time, and let us quickly see some other demo as well. Okay, right. So just the VM screen we have to share. Okay, so yeah, so now we saw that that now you can see that I just use this command of docker pull redis, and I have the redis image ready. So now I can go ahead and launch that. Okay, so now we looked into. Let us just go through that. We first saw base os, launching our web server on the base os, why it is not that viable. Then we saw that why a VM is also not a good option to launch our web server. Then we saw what are containers, and then we saw that what is the use of it. Then we just saw a simple demo of launching a container, okay, and removing it and launching again. So now let us understand what is a container. So container is basically, you can say that it is a package of all the necessary requirements that I said, or everything that you require using the image, docker image. Like for example, when I launch a container and I went inside the container with the exec command, okay, and I use the bash process to enter into it. Okay, now when I go to the slash, you can see that it has all the ingredients, all the components that are required to for a full-fledged OS. So this is container is a packaging of all this, a packaging, so which we can use it, we can build on top of that. So as you saw that we can build websites on top of that, web server on top of that. Also what we can do is we can share with people. So now like I have created this docker container, right? So now I can go ahead and create it by my own name. So let me just quickly show you that docker tag. I'll just convert the httpd into my name, for example, my name, and my web image. Okay, okay, so we are inside the docker, right? So we just need to go outside and run this command. Okay, so we can just name our container by our name, whatever is required. And just now when you see that docker images, you can see it is present, right? So now what happens is that I can go ahead and I can there's a this is not the way to create a docker image, but just for to tell you about the sharing part, that once you created a docker image, there are two ways to create. You can either use the commit command, or you can use the docker file to create the docker image. Okay, so once you have created the docker image, then you can go ahead and share this docker image to other people. So one of the ways that we saw was using the docker hub. Okay, docker hub repository, we can upload our docker images. Okay, and we can ask people to come. Now for example, If you want to go to Docker Hub and search my container images by this name, you'll get it. Okay, and you can easily go ahead inside, and you can also download them from here. Okay, so you can share your container images. So what is the use of this? The use case of this is that, so for example, yeah, let me quickly go back to the VM screen share. Yeah, just let me quickly go to the VM screen share. One moment. Yeah, yeah. So sorry for this. Okay. So yeah, so now we once you have this image ready. So for example, I go ahead and go to the inside the container. Okay, and I say that I'm using the bash. To use the bash process, I will go ahead and sorry, go to, okay, and put my own content into it. Okay, and then I once I do that, I'll just go ahead and exit from this, and you can say that I have this container running by the name of WebOS 1. So what do I need to do is I just need to go ahead and just check the IP. So let me check quickly for the WebOS 1. The IP is 2, right? So just let me go to 2. Here we can see that, okay, this is IP address 2. Okay, let me just quickly go back to that part, WebOS 1, and let me run HTTPD so that, yeah, it's already running. And let's inspect it. It's 2. Okay, yeah, you can see that I have my content up. So now, as I mentioned, that you can have your own website up here. You can deploy your own content. So now what is the use of it? So now once I've deployed my own content, say for example I run the docker commit command. Okay, and I'm using the WebOS 1 to name it as something like, okay, version 1. Okay, I've created this. So now once I go to the images part and I search by this name, then I can see, okay, wait, let me put, yeah, this one as well. Yeah, I can see this image, right? So what is the use case of this image? So now that once I go ahead and for example I push, for the push I need to pass the image. So let me pass the image. Okay, so it is pushing to my docker repository, which is submarine, and by this name. Okay, so now we have created some content. We now created into a transformed it into a docker image, and then we are pushing this docker image. So there are 3 steps into it. First we launch the container, then after launching the container we went inside the container, right? Let me just quickly show you the history. So now it is uploaded. So let me just quickly show you the history part. I launched the container. Okay, and after that I exit into the container, then I change the content, then I run it again, and then I created an image out of that container, docker image. What is the use of that? Then I can push it globally, that image. So now if I quickly stop sharing and show you the docker hub. So let me just quickly switch to the docker hub part. Yeah, let me just quickly switch to the docker hub part. Okay, as you can see here, that let us go back, and in here you can see that I have launched one container right now by this name. So let me just refresh it. Okay, so it is not up yet, but it should be up So let me check if it is pushed successfully or not. Okay. Right, just let me pushing the image. Yeah, it's pushed, right? So um, maybe it will take few seconds to display. So let me just quickly refresh it once again. It is not up. Okay, let me check. We do the process once again. Okay. So as you can see that it shows that Docker push here, and the push is referring to this part, and it is showing that it is pushed. So we can try from one part as well. We can just go ahead and delete this image. So let me delete the image. uh, yeah, let us delete this image. Okay, and let us try to pull it. If we can pull it, that means it is uploaded and shared. Okay, I deleted the image, and let me just try to pull it. Okay, so let us see that if it is able to pull it. Okay, so yeah, you can see that pulling from, I don't know, it will take some time maybe to update in the Docker Hub, but it has pulled. So now what is the use case of this? You saw that we created the image, we pushed it, and then we pulled it. Okay, so now this pull that I run, it can be run by you as well. So I'll just copy this and share this on the YouTube chat. So it means that you can go ahead and also use this command to to pull this Docker Hub from the Docker Hub, this image. So now what is the use case? That I'll just run the container from with the image that I pulled, and I'll just name it test OS. Okay, and I'll just use the image name, which is this, and version 1. Okay, so sorry, I did the same mistake that I mentioned, which is that we have to launch it in detached. We saw that why. Okay, that we have to launch it in detached, because the main service is not to provide bash, but to provide us the web service. Okay, that is why I have to go by this. So now that we have done that, let me check the inspect, and if we go by this, and we see the IP is 6. Okay, so we changed from 2 to 6. Consider you are running this from your own system. Okay, so you see the same content, right? So this is the main power of Docker. I created something. For example, this is my developer that is working in my company. He has created something, and he shared it, for example, and he created an image for all of you to use to test. It is uploaded on Docker Hub. You can come and pull the same container, and you can use it without, like, efficiently. You don't have to go ahead and create your own web server. Then you have to launch the content. You just have to pull the image. You have to install Docker, pull the image, and the same content that I created is with you as well, and it can be shared all across the globe. So yeah, you can just go ahead and share it all across the globe with this method. So this is the main power of using Docker. So I can provide it on my uh, post or on my account on Docker Hub, and you can go ahead and pull that and use that subsequently, right? So I hope that this part was clear to you, that what is the main use of Docker, or why do you use Docker, and also the part that what is the use case, and what use cases does fulfill is fulfilled by or are fulfilled by Docker. Okay, so this is the first part. I would just try I'd ask you to try installing Docker just as we like saw how to install Docker. Go ahead and deploy Docker on your own system. Okay, and then you can go ahead and launch these containers. Go for these commands, the commands that we saw, all the commands starting from the Docker run, the Docker exec, and then also you can go ahead and create a Docker Hub account. It is very simple to create one Docker Hub account. You can go ahead and create your own account. You can sign into the account. Then after you sign in, you can connect your own system to the Docker Hub account by just running Docker login. I have already logged in, and it will ask you for your login password if it is required, and if it is not required, it will just authenticate with existing credentials, as because in the .docker directory it is already present for my account. All right, then we saw that how we can we just saw the with the docker commit command how we can create our own image, and then we saw that how to push it to the Docker Hub, and then after that we pulled the Docker image, and then we deployed it. So we also saw about the Docker exec command, what it is doing, the command that you provide in the backend, what is the use of this, the command you provide in the end, right? We saw this. So I would ask you to go through all of this. Just try to do it by your own, and once we know this, the basic of how to launch containers, how to create with the commit command, how to create images, then what are the use cases of Docker, why do you use Docker? We saw that for the VM and for the base OS, what was the limitation and what was fulfilled by Docker, how we can deploy our own web server, how we can pull images. When we know about a little bit of this, the next Sunday we will try to go ahead and go deep dive a little bit more into Docker, and we'll know more about Docker. And as along with that, we will go ahead with knowing about AWS ECS, the Elastic Container Service. Okay, and how it helps us to create managed Docker container clusters, and how we can deploy our tasks on them. All right. So I hope you all got something out of this, and if you have any more questions, please ask them so that we can answer them. Okay. Yeah. So yeah. So okay. So yeah, it takes 10 minutes to actually for the image to show up. So yeah, it will take some time. uh, can Docker be used for our daily needs like all OS activation? I don't understand what do you mean by OS activation, but if you can talk about your use case, Sami, uh, I can share what I know with you. Yeah, OS activation, I'm not so sure about what you mean by that. uh, yeah, the use cases, yeah, there are a lot of use cases that can be fulfilled by Docker. So Docker has multiple images for multiple purposes, and based on those use cases you can just download an image, and you can deploy them, and based on that it will provide you the service whatever is intended for you. So for example, you want something related to security, something related to monitoring, something related to databases. You can go ahead and install a particular Docker image that will provide you that use case, and you just have to download the image, launch a container, and you have the service running within seconds. So that will be provided by Docker, right? Yeah, so any more questions, guys? If you have, we'll just go through that. I hope I could answer your question, Sami. Is that, or were you looking for something else? Please let me know. Yeah, Docker is free, but if you go ahead and use the other features, Docker provides a lot of other features like management, monitoring, and other features. So that is paid. Like for example, let me just quickly share my screen. again, and let us go to that part of, this part where it is mentioned about the pricing, right? Wait, yeah, check out check it out pricing. So let me show you the pricing. So there is a free part which is for everybody, okay, and there is also one part that is more like enterprise level kind of, which is more about providing them the right kind of monitoring, maintenance, and like that. So there is a free which is for everybody, professional is for individuals, everything in free, whatever is there, unlimited private repository. So this is on the main part. For free, is like a allocated for private repository, allocated certain amount. You cannot go beyond that, right? Excuse me. But for pro, you can have multiple private repositories. Okay, and we can go for parallel builds, and excuse me, 300 monthly hub image vulnerability scans. So this means that extra security and scanning your own Docker images. So this is at a minimal price of $5 per month annual plan. Okay, the team is like $7 per month, and it's like all the pro features you get: unlimited teams, like hub image, unlimited monthly hub image vulnerability scans, 3 parallel builds per organization, role-based access control, and a lot of things, like whoever can download your resources, whoever can manage them, and everything. So more for the pro version or the team version is more granular permissions provided to you, more features provided to you, and you know large for organization is like it's like minimum 500 user and everything. These are all like use case and directly connecting with the organization based on that. So yeah, so we can have the free version is for everybody, and yeah, we can have the other paid version as well. So yeah, thank you so much guys for attending, and we hope to attend more weekly sessions. So as we know that the situations in these times are not favorable, we are trying to do our bit. So we hope that all of you are safe and healthy, and we will try to conduct more sessions and bring out more content for you all, so that you can attend and benefit from it. And if you have any questions, or if you want to connect with us, you can go ahead and reach out to us on our all AWS cloud community LPU platforms, and be happy to connect with you all. So that was all for this session. Thank you all for joining. In the next session, we'll be seeing more deep dive into Docker, and we will go through AWS ECS, which is Elastic Container Service, uh, Docker. Okay, Docker security session. Somebody mentioned that. So yeah, looking for Docker security sessions. Okay, so we will plan something on this. We can have industry experts, or if possible we will conduct it. But yeah, this is in the pipeline, that once we know about what is Docker, what is AWS ECS, we can go into the DevSecOps part. Whatever resources we have, we can also conduct sessions, industry expert sessions for people to come in and join, and people who are working in the industry on these use cases, they can definitely share with us. So thank you for asking, uh, and we will look into this definitely. If possible, we'll definitely organize something like this, right? So yeah guys, so please take care of your health, and please see to that this virus is not spread across people, and you are not affected by it as much as possible, and try your best, and let us fight this war. Until then, keep learning, keep growing, and keep helping everyone. Thank you all, have a great and nice day. Thank you.